Hello madam, my name is Yao, leader from Group 1B. Today we are going to discuss about DC to DC boost converter. Our group consists of 3 members, me, Yao, Lo Hong, and Dan Hui. We are going to discuss all of this in our slide. So let's begin our presentation now. A DC to DC boost converter is a component that increases the voltage from its inputs to its outputs. A DC to DC boost converter consists of resistor, capacitor, diode, MOSFET, inductor, as well as the pulse generator. For example, in battery power systems, we are usually using a DC to DC boost converter because it can increase the voltage and reduce the number of cells. These are the parameters that we use in our project. So resistor 50 ohm, capacitor 100 microfarad, inductor 400 microhenry. Frequency, we have selected 400 kilohertz, and duty cycle we set at 0.65. So I think that's all from me. Hong, it's your turn now.
Hi, I'm Lo Hong. I'm going to talk about the operation of the DC to DC boost converter. This is the schematic diagram of a boost converter. The inductor is connected directly to the source, and we are using two switches, which are the solid state switch and diode. Capacitor and load resistor is connected in parallel to the diode. Basically, we have two modes operation of the boost converter, which are the on state and off state. On state is mean the switch is on but the diode is off. Off state is mean the switch is off but the diode is on. This is the general configuration of a boost converter. This is inductor, this is switch, this diode, capacitor, load which is connected in parallel to the diode, and the whole circuit is connected directly to the V source. Alright, so now we are talking about the operation. So I will separate the circuit into two parts. Here is the left hand side and this is the right hand side. Alright. So during on state, the switch is on and the diode is off. So the current from the V source can only flow in a direction clockwise in this part. So the current will only flow through the inductor, and this will not supply to the capacitor and load. So at this moment, the inductor will store the energy by generating the magnetic field. So at this part, the right hand side is shorted out from the left hand side. During the off state, the switch is open but the diode is on. So the current will flow in the big loop. And V in will supply directly to the capacitor and the load. So the energy stored in the inductor reduced and released to the load as the impedance is higher than the current. So why this has happened? Let's see. During on state, the polarity of the inductor at the left hand side of the inductor, which is connected directly to the V source, is positive. So the energy supplied to the inductor will be stored. During off state, the left hand side of the inductor, which is connected to the V source, will reverse its polarity to negative. So at this moment, the energy stored in the inductor will release to the load and capacitor in the same time. So the voltage and the energy at the load will be higher than the V source because the energy supplied to the load and capacitor is the sum up of V source and the energy supply from the inductor. And the capacitor is start charging. If the switch is cycle fast enough, the switch is here, cycle fast enough, it means open and close fast enough, so the energy stored inside the inductor will not fully release. And when the switch is on, so the right hand side is shorted out from the left hand side. So at this time, the energy stored in the capacitor will discharge to the load. And the switch must cycle fast enough to avoid the capacitor fully discharged.
Hello madam, it's Yap again. Today we are going to analyze the circuit. Analysis when the switch is closed. When the switch is closed, the diode is off and is in open circuit. We apply KVL at this loop and we get VL equal to Vin because this is in series equals to L dIL over dt. By solving the equation, and we get delta IL, this is same as DIL equals to Vin delta T divided by L. Delta T, we look at the graph and we know that delta T when the switch is closed will be equal to dt minus 0 and we get dt. Substituting delta T into the equation and we get delta IL when the switch is closed will be equal to Vin dt divided by L. Next, we will proceed to analysis when the switch is open. We know that when the switch is open, the diode is on and it will be short-circuited. We apply KVL at this loop and we get VL equals to Vin minus Vout. By solving this equation and we get delta IL over delta T equals to Vin minus Vout divided by L. Delta T is obtained from this graph. We know that when the switch is open, delta T will be equal to T minus dt. This. And we factorize T and substitute delta T equals to this into this equation and we get delta IL when the switch is open will be equal to bracket Vin minus Vout bracket times 1 minus T times T divided by L. So let's continue to the next part. Analysis. By looking at the graph, we know that delta IL when the switch is closed plus delta IL when the switch is open will be equal to 0, which means that delta IL when the switch is closed will be equal to delta IL when the switch is open. We substitute equation 1 and equation 2 into this equation and we will get this equation. By solving this equation and we obtain Vout equals to Vin divided by 1 minus D and D will be equals to Vin minus Vout divided by Vout. So let's proceed to the last analysis. Analysis output voltage ripple. From the capacitance rule, we know that Q equals to CV and this V will be equals to Vout. We differentiate both sides and we get delta Q equals to C delta Vout. and we let delta V out equals to delta Q divided by C. Delta Q will be equal to this part, M. This is dt V times dt with negative V out divided by R, and we get delta V out equals to V out dt divided by RC. We move V out to the left side and we obtain output voltage ripple, which is equal to dt divided by RC. That's all from me. Tan, it's your turn now.
Hi, I'm Tan Sek Hui. Now I am going to talk about verification through experimental result and calculation. For output voltage ripple, based on simulation, the output voltage ripple is equal to 4.693 times 10 to power negative 2 over 140.53 equals to 0.000334. Based on calculation, the output voltage ripple is equals to D over RCF, which is equals to 0.65 over 50 times 100 micro times 400 kilo equals to 0.000325. For inductor current, IL is equal to V in over bracket 1 minus D square R, which is equal to 50 over bracket 1 minus 0.65 square times 50 is equal to 8.1633 ampere. For delta inductor current is equal to V in D over LF, which is equal to 50 times 0.65 over 400 micro times 400 kilo equals to 0.2031. For IL max is equal to IL plus delta IL over 2, which is equals to 8.1633 plus 0.2031 over 2 equals to 8.263 ampere. For IL min is equal to IL minus delta IL over 2 equals to 8.1633 minus 0.2031 over 2 equals to 8.062. For measure value we get from simulation for IL max is equals to 8.313 ampere and IL min is equal to 8.113 ampere. For discussion, we can observe that calculated value are approximately same as the measure value. We assume the duty cycle D as 0.65 due to the condition D must bigger than 0 and less than 1. We also assume that frequency F is equal to 400 kHz due to its condition F must bigger than 20 kHz. In conclusion, DC to DC converter are high-frequency power conversion circuit. They come in non-isolated and isolated variety. A DC to DC boost converter is considered as non-isolated DC to DC converter. It is known as step-up converter that step up voltage from its input to its output. That's all from me. Thank you and Happy New Year.